First part of our keynote conferences. And today we're going to present Dr. Julio Guerrero. Julio Guerrero, he guides corporations around the world with the technological needs. He is the CEO and founder of Cambridge Research and Technology, a consulting firm leading in science engineering in Cambridge, Boston, and he's a member University Grad Committee in Hong Kong. Julio Guerrero, he's going to talk about decarbonization, energy and climate change, the energy transition, and the use of safe and sustainable energy, innovations, global trends in renewable energies, and decarbonization processes. Welcome, Julio Guerrero. Thank you for being with us today. The floor is yours.
Start my presentation. I would like you to keep in mind the first 3 slides of this presentation because the theme of the presentation will come back to these 3 first slides, okay? What you see in the right side of this slide is a pile of guano, which, as many of you may know, was the main fertilizer in the 19th century. This picture is in Peru, and as you can see, this pile is about 25 meters high, and people who you see working there are the ones who basically are helping with the taking these into the ships. As a reference, by the middle of the 19th century, about 2/3 of all the workers in the, let's call guano industry in Peru and South America, especially in Peru, 2/3 of them were from China, in particular from the south of China. This picture here shows something very interesting. On the left side, you have this pile of natural fertilizer. And on the right side, you see 2 very famous chemists, Fritz Haber and Carl Bosch, who came up with a way using non-organic chemistry to produce non-organic fertilizer. That per se defined the end of the need for guano. And from that moment on, the world embarked into the production in industrial quantities of fertilizer. This is a very interesting ship that has been for many years next to Wall Street in New York, in Manhattan. It's called a Peckins ship. I've been there more than once, and it's like a museum, and it's very interesting. It's a German ship that had the business of transporting basically fertilizers from South America to Europe. So you have the first picture was using a available source of wealth for some countries in South America. At some point, science and technology defined the end of that. Unfortunately, for whatever reasons, the community, the scientific and engineering community, probably didn't perceive the arrival of this innovation that defines its end. And here we can see the means by which industrialized countries, this is from Germany, transported the natural resource to Europe. And kind of an ironic is that the inventors of the replacement were also from Germany. Okay, so now the presentation today will go around these 4 topics, okay? How the national strategy that has to handle what I will call the energy revolution or transformation has to deal with several aspects. On the top of this tetrahedron, I will talk about how the G7 are addressing renewables and decarbonization. On the bottom left corner, you can see that I will talk about the trillions of investment that are going to take place in the next 4 or 5 years in the United States. What are the world trends and opportunities and challenges for science and engineering? You will see that I will be walking through this list of entries in the contents. These infographics, I think it's quite relevant. You can see in dark blue that about 75% of oil and gas companies are national oil companies, and the other 25% are private companies. You can see that mostly in North America and Europe, you don't see national oil companies, they are private. You can see that Saudi Aramco, the largest producer of oil and gas in the world, produces about or generates about 6 million barrels per day. For comparison, Peru produces about 0.04 million of barrels per day. And you can see it's self-explanatory, the arrows that go from the Middle East to Asia and to the United States, Africa, etc. And you can see that I will, in some way, not so significant contribution of the production of oil and gas from the Latin American countries. Now, just to give you a perception about magnitudes, the GDP of the United States is close to $22 trillion. Okay, I will emphasize that trillion is 10 to the 12, right? So 1 trillion is $1 million dollars. The GDP of Peru is significantly smaller, as you can see in the slide, right? Now, the United States, so the next 3 to 4 slides will remark how the oil and gas market is behaving currently in the United States. Then I will talk about Europe, and then I will talk about the Middle East, one slide about Peru, and then I will transition to the challenges for engineering. So you can see that the United States has become a net annual petroleum exporter. Okay, that happened last year during the pandemic. And you can see have marked in red here, the brown is the production. You can see how the production has increased. And in maroon, you can see how the net imports have reduced. And that has helped in a significant way to that transformation. Okay, the share of imports from the OPEC countries and Persian Gulf has declined in a significant way. So in the United States, there is an expression that was used several years ago, which is becoming energy independent. Although not all the energy in the United States is generated from hydrocarbons, you can see that that is starting to happen. Natural gas has played a significant role on this. You can see in light blue, gas, and in dark blue, coal, and you can see how gas is displacing, de facto has displaced coal. Here on the right side, you see a distribution of the electricity generation, the sources. I could have talked about energy for other activities, but I chose, because of the limited time, to focus on electricity. So in 2020, you can see the coal is about 20%, while renewable is 20%, nuclear 20%, and natural gas 40%. I would like you to keep in mind, since the core of this presentation is renewables and global warming, to try to keep in mind this number, that renewables are about 20%. Very quickly here, you can see a distribution of the sources of energy in the United States, and you can see the coal has declined. Natural gas has almost taken completely coal. And in maroon, you can see nuclear in the last, I would say, 15 to 20 years has stayed constant. And renewables has increased I would say in a significant way since the middle of the last about 2005, it started to become constant. And here we can see a zoom into the electric generation from renewables. So basically what is painted in this graph in green, here there is a zoom into that, and you can see the most is hydroelectric. Wind has almost started to match hydroelectric, and solar is getting up to there. This shows a significant commitment to change the distribution of sources of energy from renewables. Now we will transition to Europe. I would like to remark that the European Union produced around 40% of its own energy, while 61% was imported. And I will leave it there because of the limited time that we have. Many people are under the impression that Europe has reached a quite good balance between renewables and non-renewables. So you can see here in the horizontal axis, you see countries, and in the middle is, let's call the average, the European Union. And you can see in dark blue, fossil fuels, which is close to 40%, and it looks quite nice. Nuclear, hydro, renewables, etc., cover the other 60%. But we have to be very careful about making that generalization, because if you move to the left, you can see that the distribution of sources of energy is different for some countries, and also from the far right, where you can see France, which is mostly nuclear, but you can also see Poland, which is mostly fossil fuels. So again, the middle point, Europe, is the average, and then you can see how it manifests in the other countries. Now let's try to move to the Gulf, the Persian Gulf, or the Middle East. In the horizontal axis of this plot, you see the percentage of the shortfall in government revenues under a low carbon scenario. So what this is trying to communicate is how the transition from hydrocarbons to a low carbon scenario would impact the economy of the countries in the Middle East. They, of course, they are aware about this, and they are taking action about that. And the next two slides will communicate how that is taking place. In the vertical axis, you can see the dependence of their economy of that on the hydrocarbons. And you can see Saudi Arabia is the one that depends the most on hydrocarbons, its economy, and you can see that it will be impacted. I mean, its government revenue will be impacted by about 75% in a low carbon scenario by 2040. These will have significant repercussions in geopolitics and the economics worldwide. And so what are they doing? They are aware of this, okay? So, well, those who like soccer, they are thinking about Qatar and the World Cup. Just keep in mind that they are starting to invest some of their resources on trying to feed their system, all their industry and all their activities with renewable energy. And you can see the targets here, and you can see that Bahrain, 5% by 2030 for electricity generation, Kuwait, 15% by 2030 for electricity generation. So you can see, well, there is a large distribution of how much they are investing, but all of them are trying to achieve very ambitious targets by 2030. Here, kind of the same information expressed in a different manner. You can see by 2017 how much the Emirates were investing on renewable energy. Hopefully, the investment will grow in the near future. This is Peru. By the way, you can see on the bottom right corner of all the slides, there is a number, which means that all the information I am presenting has the proper reference to the sources where I'm getting this from. So you can see that in Peru, the electric energy generation has a significant dependence on hydrocarbons. You can see natural gas and oil. Of course, it has a very good share of biofuels, waste, hydro, renewables, but still, it seems to me that about 50 or more than 50% of the electric energy, at least by this source, is generated from hydrocarbons. Gas, 30, this is still Peru, gas 34%, hydro 59%. And if you add biosolar and energy, you can see that it's about 4%. 5%, 6%, 1 plus 2 plus 3, 6. Remember, I told you a few slides earlier, keep in mind that in the United States is already 20% and Europe is also close to that. So I think I have compensated for the time. So I will now try to slow down in order to communicate in a more calm way the remaining second half of this presentation. This slide here tries to communicate the annual contribution on CO2 emissions per country. And I have put inside red circles the United States is 5,600 total emissions, India 2,000, and China 12,000. So ballpark, China has contributes or generates almost twice as much as the United States, almost I would say 5 times as much as India. But we have to keep a good eye on this information because, as you know, 2 of these countries are the most populated ones. Then you can see by the distribution of colors how much the other countries are contributing to the CO2 emissions worldwide. It doesn't mean that only the ones that emit the most has to try to change. It's a work for everybody, but this gives you a graphical description of the distribution. Here, this is kind of the same information, but I'm trying to emphasize again India, United States, and China. Okay, you can see that's coal, other coal use, and fossil fuels, excluding coal. So how this contribution of CO2 is coming from these hydrocarbons. Okay, so now the oblong red shape on the left side of this slide tries to remark the area of COPIMERA, right? So those are all the countries that are involved in this organization. This is the projected impact of climate change on agricultural yields. So basically, how the climate change will impact our sources of food, what we eat. You can see from -5 to -25% is the change in agricultural productivity between 2003 and 2080. And that's a significant piece of information. This is basically telling us where most of the social unrest and most of the conflicts will take place. As you know, when most people can eat, then usually that's where the social unrest takes place, as well as wars and conflicts and so on. So this is basically a message, not to our brains, but this is a message to our stomachs. This is a very powerful piece of information. And you can see what happens in the north, right? That it doesn't seem to affect in such an impactful way their agricultural yields. Now, out of all the areas where the global warming will affect, there is a very common term that is being used, which is that sovereign climate risk. Okay, as those who are familiar with finance are familiar with the expression sovereign funds, right? About the money. But this is about the sovereign climate risk. And I would like to remark that flooding and water stress are the ones that seem to will affect the most our planet. Of course, there will be heat stress, hurricanes, and so on. Here, in a more numerical way, I have marked the ones that are most impactful. You can see that out of 7+ billion people, about half of the population of the world will be affected mostly by flooding and water stress. Okay, the GDP, you can see in trillions of dollars, again, trillion, 10 to the 12, how the floodings and water stress will affect the regions. And the global percentage of the population is quite significant. 40% will be affected by flooding, about 40% by water stress. The global percentage, this is not just, let's say, the COPIMERA region, okay, but globally, about 35% of the agriculture will be a high risk due to the water stress. Flooding will affect that too. Okay, so now walking through the table of contents, here I will now talk about what engineers like most, right? So we are presented with challenges. Some people like to call them problems. I prefer to call them challenges, and the opportunities for what we do best, which is analyze, invent, and come up with solutions to these challenges. So we need to drive huge leaps in clean energy in order to address the current situation, okay? By the year 2050, which is about 30 years from now, almost half the reductions will come from technologies that are right now at the demonstration or prototyping phase. I will try to emphasize this, okay? Many people, including colleagues, engineers, wrongly think that the solutions are already available, okay? I want to remark that no, the solutions are not available yet. The solutions are being developed. They are at the demonstration or prototyping phase. And those solutions at the demonstration or prototyping phase are not mostly in the south of the planet, but they are mostly on the north of the planet. So coming back to the first slide about the guano and the two German researchers who came up with the inorganic replacement of guano, these people who I think one or two of them got also the Nobel Prize, they were working, of course, on the prototyping, the conceptual part of their discovery for many years before they came up with a solution. While in the other countries that were producing the guano, they were still thinking the guano was going to keep them wealthy for the rest of their history. Okay, so right now, my dear colleagues, there are people who are working on the solutions that hopefully will help by the year 2050. And I think that's a great opportunity for all engineers and researchers in the COPIMERA to make a significant change in the way we practice our profession. And it's up to us, number one, to become aware of the opportunity, and number two, to be active players in the implementation of the solutions. Here, in the next 3 slides, I will share with you 3 pieces of information that remark some of the challenges that are embedded in our region. Okay, as you can see, by the year 2050, more or less, we will reach a plateau of about 10 billion people, okay, worldwide. However, as you can see in green color, the developing regions, okay, of the planet will have about 9 out of the 10 billion people. So out of 10 human beings, 1 will live in the developed region of the planet and 9 will not. Second, So that's about the distribution of population. Now let's talk about the knowledge. You can see here in the 1800s, in kind of purple color, how the world population was distributed, right? And you can see North America was 0.7, Latin America 2.5, and then Asia 65%. As you can see, by the year 2050, 30 years from now again, the population from Europe will be about 7% of the planet. Latin America will be about 10%. Africa will be about 20%. So between Latin America and Africa, there will be about 30% of the population will be in these regions. And what is that very interesting challenge? This is the global technology map. Look at the regions that I have just mentioned that will have the most population by the 2050, and look at the distribution of global technology. So the countries where there will be more population, the most population, they are ranked in the percentile of this. This is a percentile map. You can see that unfortunately, the global technology is the least available in that area. Personally, in my humble opinion, it is completely wrong to say that the responsibility or the reason why this availability of knowledge and technology in this area is smaller than others, to blame others. I think the responsibility of us and engineers and researchers to try to make that change. So here I will try to share with you how this challenge is addressed in innovation hubs. Innovation hubs are areas, regions in some of the countries in the north where most of the innovation happens. I happen to live and work in one of them in Cambridge, in Massachusetts. In the center of this diagram, you have in maroon the MIT, the Massachusetts Institute of Technology, which is about, I would say, about 6 to 7 blocks long and about 4 blocks wide. And all the industries around this center of innovation, or all the industries, and you can see not only, you don't see one industry, you don't see, for example, only oil and gas, you see entertainment, you see computer, you see biomedical, etc. And the innovation happens here. The eighth, if all the innovation that has been generated in this innovation hub were a country, this will be the 8th largest economy in the world. And this happens because there is a magnet to attract investment and researchers and engineers from all over the world. In the next, in the round table, one of the members of the round table, Adam Paxson, he comes from the MIT, and he's right now running the innovation for the manufacturing in one of the 4 top fuel cell companies in the United States. I will talk about that in a few slides. I won't talk about this more than 10 seconds, just to tell you that this on the right side has a mapping of 24 innovation technologies from Draper Laboratories, one of the places where I have worked, and that was mapped to a myriad of applications in the oil and gas industry. That's the reason why, for example, Schlumberger, Saudi Aramco, Shell are here. Oh, I almost forgot. Somewhere here in this corner, you cannot see that right now, but Moderna, the company that created one of the 3 famous American vaccines, is here. Its research center is there. So literally, the vaccine against COVID was created there. And if you cross the street, I really mean you cross the street, across the street, you have Pfizer, and you have the research center of Pfizer where they came up with the COVID vaccine from Pfizer. So this is an innovation hub where things happen, and things are happening related to also alternative to hydrocarbons. Okay. The next 3 slides will be about the magnitude of investment that will take place in the coming years. United States is investing at least $1 trillion, maybe 2 to 3 in the next 4 to 5 years. And it will be focused on stimulating the improvement of the infrastructure in this country, but also a significant part of that investment will go to stimulate alternative sources of energy, green energy, the grid, and so on. The sources for that funding, I wanted to invest time on this, but unfortunately, we won't have to explain how that is funded, okay? Now, here in red, this is the second part I would like you to remember, as I did when I show you the picture of the WANO and the researchers in Germany. Here, the current administration of the US government is putting climate at the center of the foreign policy. Why is this relevant? Because there are people from many countries in Latin America in this conference, and I would like to remark that, okay? It is not oil, it's not trade, all the typical focuses of foreign policy. The focus of the foreign policy will be climate, and that's extremely relevant for those who are decision makers or influences in the different governments in Latin America. That's a good way, or that's something that has to be kept in mind when we are talking about the magnitude of the investment that it will be for green energy. This slide meant to explain how one can access part of this funding for research and development in the United States. Just 3 things: DOE, the Department of Energy, that will be something like the Ministerio de Energía y Minas in Peru. There are different ways in which you access this innovation, okay? Energy grid is one of the areas that will be the focus for this investment. It is a significant focus on helping the development of electric cars. $174 billion in the next 10 years is a quite significant investment trying to stimulate the development of technologies that will help with this. Okay, so the opportunities. This is the part that I think we as engineers will enjoy the most. So I will spend the next 5 to 10 minutes on this. What should be the strategy for the countries in the region for the next 10 years and 30 years? Because as engineers, when we are presented with challenges or problems, I know we all are thinking in our minds, okay, so that's the challenge, that's the problem, if you wish. So what do we do? What should be the strategy, right? So I don't know. No, this is just a general presentation. Of course, I have a team who works on this, but I just want to remark this. The WANO is about to be replaced by inorganic chemistry. What do I mean? Let's make an analogy between the WANO and the hydrocarbons, okay? And let's make an analogy between inorganic chemistry and all the developments that are taking place in some of the developed countries. So we can continue having the conversation about how to get the best from the WANO, while in somewhere in the north of the planet, they are talking about how to come up with an inorganic chemistry that will replace the WANO. I hope you understand the analogy that I'm trying to bring to your attention. Remember, by 2050, almost half the reductions will come from technologies that are currently at the demonstration or prototype phase. In other words, what I mean to do is try to motivate, try to inspire colleagues. Well, that may not be a good idea because, again, you are repeating that mindset about what is the next raw material that we should be mining in order to sell. So what is the next one? While what I'm trying to do is to motivate you to think about what is the next inorganic chemistry that can help, okay? So some of the new inorganic chemistries that are happening, I'm trying to keeping the focus on the analogy, okay? Fuel cells, okay, is one of the, I won't talk about solar and wind because I think that will be touched or addressed during the roundtable. So I will focus mostly on fuel cells, okay? Plug Power, which is one of the, these are the 4 companies dedicated to fuel cell that are actually traded in Wall Street, okay? And Adam Paxson actually works and is responsible for manufacturing of Plug Power. So this is basically like the front end of innovation, okay? Ammonia engines that are gonna be using instead of hydrocarbons that generate CO2. Ammonia engines is another area that is at the front end of innovation. I will leave it there. And now this slide is to show you what is one of the key challenges for ammonia or hydrogen, okay? I won't go, I cannot go because of the hydrogen can be produced, okay? It's not that nobody knows how to produce them, but unfortunately, as the bottom left picture shows, it's being produced with a lot of pollution. So the alternative is to produce ammonia or hydrogen, but green energy, green hydrogen and green ammonia. The front end researchers are looking at how to use electricity generated from renewables such as wind, for example, or solar, and use that energy in order to generate ammonia and hydrogen in a green way, okay? And then use that produced hydrogen and ammonia and transport that, because one of the key problems that we have is on the left and right side of this slide, you can see wind and solar, but you cannot transport the energy, which is one of the advantages of transporting the hydrocarbons. So the alternative to that right now is how to use that renewable energy to generate hydrogen and ammonia, pack it, put it in pressure vessels, and transport that, because the infrastructure for transporting is almost there, okay? There are pros and cons for hydrogen. But because I want to leave enough time to the roundtable, I will limit this. Just to let you know that storing in batteries versus hydrogen, storing in batteries is good for short periods of time, but for extended periods, it's better to use salt domes and others, okay? So again, I have tried to share with you information about finance, investment, innovation in the G7 countries, as well as the Middle East, the magnitude of the investment that is going to take place in the north of the planet in the next 4 to 5 years, the world trends, okay, the opportunities and challenges for science and engineering. And all of that, I think, should be taken into consideration for the national, for shaping the national strategy. I would like to emphasize the bottom corner of this tetrahedron, which is I encourage all the people that interact with the decision makers in the countries of Latin America to rethink the exploration and the production of its hydrocarbons. In other words, if the pile, the hill of fertilizer in this picture on the right were the hydrocarbons, okay, and you are still having the discussion about how we can produce more hydrocarbons slash guano, while the rest of the planet is looking at what will be the technology that will replace the hydrocarbons by the year 2050, then we will miss again a very important opportunity. Okay, Karen, if there were at least one question, I have tried to run, I scheduled for 1 hour. I have presented in a lot less than that. If there were at least one question, I think that would be greatly appreciated.